Okay, welcome to the second session of electrostatics. So today we will start with types of charging. Yesterday we have been through up to properties of electric charge. So today we will start from types of charging. Okay, so make the heading. Let me black. Okay, types of charging. Sorry. Make the heading types of charging. In types of charging, there are two types of charging. One is charging by conduction, charging by conduction, and the second one is charging by induction. Charging by induction. So, what is charging by conduction? Make a headline: charging by conduction. What does it mean? If I will have one charged body, it's a charged body. Charged body. Let's suppose it is having positive charge, and I will keep in the neighborhood or in the direct contact of another body. This is another body. So what happens by conduction of charge, it acquires the same charge connecting with the body. Okay, so this is charging by conduction. So what does it mean by charging by induction? Let's see. Okay, charging by induction. Charging by induction. Charging by induction. I will I will explain it through diagrams. Okay. I have one charged body. Let's suppose it is having positive charge. This is a conducting body. This is a conducting body. And in the neighborhood of this charged body, I have kept another body, and this is a neutral body. This is a neutral body. This is a neutral body. Neutral body means due to charging by induction, what happens if I will place a neutral body near a conducting body or charged body? So what happens? Uh, the conducting body has positive charge, then the side which is nearer to the conducting body will acquire negative charge. Okay, opposite charge, because opposite charges attract each other, and the other side will acquire positive charge, and this positive charge is called pre-induced charge, or this negative charge is called bound induced charge. Okay, so so what happens next? If I will put, this is the positive charged body or charged body. Now what I will have to do, these are negative, I will have to connect it through earth. I will have to give it earthing, proper earthing connection. So what happened? These positive charges go into earth, and only negative charges remains in the second body. This is the second body, this is the first body, remains in the second body. So what happens with us? This is positive charge, and then second one becomes negatively charged. Both are oppositely charged. Okay, do you understand? You have to conclude one point from this. As you can see, by by charging uh, charging by conduction, what we have, charging by conduction, both are same charge, both both same charge. Okay, both uh, both same charge, both same charge, both same charge, but charging by induction, opposite charges, we found opposite charges. Okay, this is the conclusion from types of charging. Okay, so next we will move to frictional charging. The next part is frictional charging. Okay, okay, fine. The next part is frictional charging. Okay, heading of frictional charging. Frictional charging. What do you mean by frictional charging? Frictional charging means if we keep two bodies in contact due to friction between two selected pairs of bodies, what happens? The charges are induced. Okay, like we have few examples of these frictional charging are positive charge and another is negative charge. We will see. Let me draw it straight. It becomes okay. One is positive charge and another is negative charge. We'll see which are the bodies which becomes positive charge due to friction and which becomes negative charge. Dry hair, and in the negative charge section there is plastic comb. You have to make note of it. Sometimes short questions came from this section directly asking about which one became positive charge or which one became negative charge due to frictional charging. Okay, you have to remember these names. That's why I am writing it. Glass rod, and here silk. Third number, plain carpet, rubber shoes. Fourth, woolen cloth, amber. 5, woolen coat, plastic sheet. 6, flannel or cat skin. It becomes positive, and ebonite rod becomes negative. Okay, these are the few examples. You have to remember it. Next, I want to discuss about point charges. It's a very important concept to understand. What do you mean by point charges? Okay, let's look into it. Point charges in electrostatic means either the entire charge is concentrated at a point or distributed on a body such that we can assume its entire charge is concentrated at any point. Okay, so what does it mean by? The charge distribution should be like this, that we can consider the charge is concentrated at one point. Okay, so I can write either the charge is distributed on a body such that we can assume its entire charge is concentrated at any point, or or the entire charge is concentrated at a point. Hope you understood it. Okay, so let's move to our topic finally. The start of the topic, or the start of okay, what happening? Sorry. Okay, so I will start with Coulombs law in electrostatic. Very very important point. That is your Coulombs law in electrostatics. Listen to it with your full concentration. Okay, so what does the statement shows? According to Coulomb's law, the force between the force of interaction, or you can say the force between two point charges, or you can say two test charges, point charges, varies directly as the product of magnitude of the charges, and varies inversely as the square of distance of separation between the charges. Okay, don't worry, I will understand it. You will understand it in a very good way, like this. The force of interaction is F, and it directly proportional to the product of two charges. So let's suppose I have two charges. One is Q1 having charge Q1 and another is having charge Q2. Okay, and their magnitude is Q1 and their magnitude of charge is Q2. The second body having magnitude of charge is Q2, and the distance of separation between their centers is capital R, small r. Okay, so what Coulomb's law said? Coulomb's law said that it varies directly to the product of their charges, like that is F directly proportional to Q1 Q2, and the second F is inversely proportional to the distance square of distance between the charges. F inversely proportional R. So combiningly, I can say F is proportional to Q1 Q2 divided by R square, isn't it? Okay, so as you know, I can write it as this, and then by eliminating the proportionality constant, I have to write it like this: a constant k, q1 q2 divided by r square. What is this for proportionality constant? What's its value? this proportionality constant is called what? It depends upon the nature of the medium. So upon nature of medium, and it is called what? Dielectric constant. Dielectric constant or force constant, we can say, and we will see it later. What does it means? Okay, or force constant, we can say. If we are talking about the free space, its value will be 1 by 4 pi epsilon naught, where epsilon naught is permittivity in free space, where epsilon naught is permittivity in free space. And if I talk about in general any medium, then I will have to write it as 1 by 4 pi epsilon. Epsilon is permittivity of the medium I have taken. Okay, so let's have some data about the values of it. Epsilon naught has the value 8.854 into 10 to the power minus 12. What will be its unit? If I will have to calculate its unit, F is equal to sorry, F is equal to 1 by 4 pi epsilon naught q1 q2 divided by r square. 1 by 4 pi, I have to calculate the unit of epsilon naught. F is Newton into meter square divided by Coulomb square as uh, uh, by 4 pi epsilon. Okay, as epsilon naught. Okay, epsilon naught will be Coulomb square Newton into meter square. So what does its unit? Coulomb square Newton into meter square. This is the value of epsilon naught. So what's the value of 1 by 4 pi epsilon naught? Its value is 9 into 10 to the power 9 Newton into meter square divided by Coulomb square. Okay, hope you remember these two values. Okay, it will be good for you. Okay, so in today's lecture we will have to do up to this. In next lecture I will discuss about the dielectric constant, relative electrical permittivity, units of charge, and few more stuffs. Okay, thank you for today.